Section 2.8, Distance and Midpoint Formulas, Circles. The distance formula shown here can be used to find the distance between 2 points. To find the distance, we subtract the x-coordinates and square it. We subtract the y-coordinates, square that, add those two quantities together, and take the square root. Let's look at an example. Find the distance between these 2 points. We want to express our answer in simplified radical form, and then also approximate it to 2 decimal places. To find this distance, we take our distance formula, and it doesn't matter which point you consider point number 1 and point number 2, but typically we take them in the order given. So if this is point number 1, then x sub 1 is negative 1, y sub 1 is negative 3, so we write those in. And then for x sub 2 and y sub 2, we write in those values. We start to simplify. 2 minus a negative 1 is 3. 3 minus a negative 3 is 3 plus 3 is 6. So that gives us 9 plus 36. So we get the square root of 45. Now we want to express that answer in simplified radical form. To do that, we look at 45 and we consider its factors. And the factors that we're interested in is whatever the greatest perfect square that will divide evenly into 45. Perfect squares are numbers like 4 and 9 and 16, 25, etc. And 9 is the biggest perfect square that divides 45 evenly. So we write 45 as 9 times 5. And then the square root of 9, because it's the perfect square, we get 3. And the square root of 5 we can't do. So basically we're breaking the square root of 45 up into the part we can do and the part we can't do. And so we've completed that first request of writing it in simplest radical form. Now we want to round to 2 decimal places. So we use our calculator, and you can either type 3 times the square root of 5 on your calculator, but in case you've made a mistake while simplifying, it's probably better to go back to the square root of 45 and do that directly. In either case, you get 6.71 when you round it to 2 decimal places. Next, we want to look at the midpoint formula. The midpoint formula allows us to find the point that lies directly between any 2 other points. And to find the midpoint, you're going to average the x-coordinates, and then you're going to average the y-coordinates. Let's look at an example of that. To find the midpoint of these 2 points, we'll use our midpoint formula. We start by averaging the x values, so the x values are 1 and 7. When we add those up and divide by 2, we get 4. And then we'll do the same for the y coordinates. We add up the 2 and the negative 3. That gives us a negative 1 all over 2. And so that simplifies to negative 1/2. Next, we're going to look at circles. A circle is the set of all points that are equidistant from a given point, which we call the center. And then if you look at the distance from the center to any point on the circle, we call that the radius. This is the standard form for the equation of a circle. H and K tell us where the center is, and R tells us how big the radius is. In this example, we're asked to write the equation of this circle. So we use the equation and we find our x-coordinate, which is h. So h is 0, we write x minus 0 squared. And the y-coordinate of the center is negative 6. So we have y minus the negative 6 quantity squared. And then that equals the radius squared, 10 squared. We can do some simplifications. X minus 0 can simply be written as x, so that is x squared. Y minus the negative 6 is y plus 6. So we get y plus 6 quantity squared equals, and then 10 squared is 100. And there's our equation. In this example, we want to graph this circle. So we'll want to find the center and the radius by looking at our equation. So x minus h, this x plus 3 must give us an h of negative 3 because it would be of the form x minus the minus 3. And then for the y-coordinate, y minus 1, so our k value is 1. The signs can be a little tricky because there's negatives in the formula that means that the signs show up the opposite when we're looking at them here. So sometimes you can think of it as changing the signs when you put them into the formula, changing the signs when you take them out. Then with the radius, you need to be careful. It's not 4. In this position, it's r squared. So r squared is 4. So our radius is the square root of 4, which is 2. Now we want to graph this circle. So we look at our center and we plot the center point at where x is -3 and y is up 1. And then since our radius is 2, we're going to want to go in all directions. We can plot the 4 easy points up, down, left, right. And after plotting those points, we carefully draw a circle around all those points. Now we'll look at general form. General form is when everything's multiplied out, so you just have a lot of individual terms. X squared and y squared will have coefficients of 1 when it's a circle. The other coefficients of x and y can be any real numbers, and there will be a constant which could be any real number. So let's take a look at an example. Here's an equation that is given to us in general form, and they want us to graph it, and they also want us to write it in standard form. The first thing we need to do is start to reorder these terms. So we'll put our x squared term first, then we find our x term, so this 4x term, we write it next. Then we'll leave a space, which I'll talk about in a minute, plus the y squared term, then the y term. We'll leave a space here, and finally we take our -1 and we transpose it to the right side of the equation, make it a +1. Algebraically, that's you added 1 to this side so it disappeared, and you added 1 to this side so you end up with 1. The reason we have those spaces is we want to find a constant term we can add here to do what's called completing the square. Remember, in standard form, we're going to want a perfect square binomial. So we'll have a method for finding a constant that once we put it here, we can factor it. Those two factors will be identical, so we can write that as a binomial squared. The trick that we use to do that is we take half of this middle term, which is a +2, and then we square it, which would give us a +4, and we'll put that right there. And if we add 4 to the left, we'll have to add 4 to the right. We then move over and we'll complete the square in y. So half of -4 is -2. -2 squared is a +4. We always end up having it be a positive in this location because you square it, so whether it was a positive or negative, you end up with a positive. And again, if we add 4 to the left, we have to add 4 to the right. So now we want to make this trinomial become a binomial squared, and we also want to add up these values over here on the right. So let's do that first. 1 + 4 + 4 is 9. So this is the part that's going to seem the trickiest. Let's start with thinking about factoring. Remember, when you factor a trinomial, you write the 2 parentheses for your binomials, and then to get an x squared, we would go with x and x. To get a +4, there'd be other options, but it turns out that the correct option for this one is the +2 and the +2. And the reason is those not only multiply to give me a +4, but the outer is a 2x, the inner is a 2x, and that adds to 4x. Since these two binomials happen to be identical, we can write it more simply as x + 2 quantity squared. So we can write that down here. And again, we can look at the factoring, I'll call it the long way because I'm going to show you a shortcut in a second, but to factor this, we would write our parentheses and we have the y and the y. And then to get this positive, we want the two negatives, and a 2 and a 2. And notice that if you do the outer and the inner, you get a -2y and a -2y. It will combine. So this is the correct factoring. And again, it's going to seem like a coincidence, but it's not. We selected this constant carefully so that we would end up with a perfect square binomial, so that our factors would be identical. So we can write those down in here. Now, I said that I was going to give you a shortcut. All of this can be skipped by using the following. Because we carefully selected this term by taking half of this and squaring it, then we guaranteed we had a perfect square binomial. So x squared, you're going to keep the x, and then it's the thing you had after you took half of it, but before you square it, including the sign. So half of a plus 4 is a plus 2, and then over here, the y, we keep the y, and then the thing we had after we took half of it, but before we squared it, was a negative 2. So that should make this factoring go fairly efficiently. And now we have our equation in standard form. We're not quite done. They want us to graph it. So if we compare our equation to the standard form, we can find our h and k for our center. The center's x value. Again, you got to be careful with these signs. It's a plus 2, so that means the x coordinate is a minus 2, because it's a minus 2 is why we're seeing that plus. And then the y coordinate is 2, y minus k, it's y minus 2, so that's just a positive 2. So that's our center. Our radius isn't 9. Our radius squared is 9. So our radius is going to be the square root of 9, which is 3. And they want us to graph that. So we plot negative 2, 2. So back 2, up 2 is our center. And the radius is 3. So you go up 3, down 3, left 3, and right 3. And then you can draw your circle through those points.